Hello everybody, my name is Yingwei Zhang. I'm a research assistant from Institute of Computing Technology, Chinese Academy of Sciences. I'm very happy to introduce our recent work, a feature adaptive learning method for high-density sEMG-based gesture recognition. This is the content of our report. I will introduce the background, the proposed method, the experimental analysis, and the conclusion respectively. Gesture recognition aims to recognize an individual's meaningful movement expression of hands, arms, or even body. It is of utmost importance in many human-computer interaction applications, such as medical rehabilitation, sign language recognition, and virtual reality. Currently, there are many existing gesture recognition solutions, such as the computer vision, the initial measurement unit, and the Electromyography-based gesture recognition. Among the various solutions for gesture recognition, sEMG show excellent potential in gesture recognition area by directing sensing and decoding human muscle activities. Existing methods generally assume that the offline training and the online testing data stream have a feature space. However, this assumption does not hold in many real-world scenarios. The decrement and the increment of electrodes will cause changes in sEMG feature space. To handle this kind of changes, one straightforward approach is to build a new model with additional electrodes. However, this kind of approach is limited by some factors. To address this challenge, we propose a novel feature incremental and decremental ensemble learning method in our research, namely FIDE. FIDE is composed of two main parts: the spatial constraint weighting-based stratified random forest, and the adaptive perceptual methods. In our research, we define the feature evolution process as the augmentation of electrodes is usually planted and expected. However, the vanishment of electrodes is usually unexpected, causing some environmental factors, such as motion artifacts, hair, and sweat on the surface of the skin. These are more like the realistic process. During the process of constructing the stratified random forest, we define the concept of distribution difference, which can be used to calculate the distance of two electrodes. Then we cluster different electrodes by the k-means-based electrode clustering method. Finally, we build the stratified random forest by constructing decision tree for each group of electrodes. During the process of feature decrement, we reconstruct the missing feature by calculating distribution difference and metric sketch. During the process of feature increment, we define the selection criteria for individual classifier and two different tree updating methods. Then we will introduce the experiment briefly. We conduct experiments on the benchmark datasets and the real-world scenarios. On the benchmark dataset, we select 3 datasets and extract 6 kinds of different features. The experiment verifies the effectiveness of FIDE method. We also design a system, namely MCS, to further verify the effectiveness of FIDE in real-world scenarios. The experiment in real-world scenarios also verify the effectiveness of FIDE. The last part is our conclusion. sEMG-based gesture recognition is widely studied in human-computer interaction area. In this paper, we focus on expected feature increment and unexpected feature decrement challenge in gesture recognition and propose an adaptive ensemble learning method, namely FIDE. FIDE defines two important concepts to build the stratified random forest and continuously update the existing model. Comparative experiments on 3 benchmark datasets and 2 real-world scenarios all show the effectiveness of FIDE. That's all of our report. Thanks for listening.